Hold on tight, everyone. An object is drifting through the solar system between Earth and Mars, and no one knows exactly what it is. It's about the size of a detached house and rotates on its axis every 5 minutes.
Now, scientists are claiming that this thing is not a natural object, but an artificial space probe.
If you're interested in topics like this, please do subscribe to the channel. It's just a click for you, but it helps me enormously.
And for those of you who have already subscribed, you can appease the YouTube algorithm with a thumbs up. 5,000 likes should do the trick. Thanks a lot, guys. So what is going on out there in space? In the year 1998, astronomers discovered a small object by the name of 1998 KY26.
It sounds as though the scientists fell asleep at the keyboard, but what lies behind this name is anything but boring. The object is traveling along an orbit between Earth and Mars, has a diameter of about 11 meters, and rotates at breakneck speed, once every 5.3 minutes. As we know, it takes Earth 24 hours to complete a rotation on its axis, but the rotation is actually the least of the object's peculiarities. Its orbit is far stranger. KY26 belongs to a class of objects that scientists refer to as dark comets. These are bodies whose orbit is influenced by what is known as non-gravitational acceleration. Something is slowing them down or pushing them along, and this cannot be explained by gravity alone. We are familiar with this phenomenon in normal comets. When the sun vaporizes the ice inside them, a gas outflow is created which pushes the object in a slightly different direction. Like a small rocket engine, comets have a tail, a glowing shell of gas and dust known as a coma. But KY26 doesn't have one. No tail, no coma, no gas, nothing, yet it behaves like a comet.
But it doesn't look like one. And that's the mystery that has puzzled science since its discovery, and now the evidence is mounting for a non-natural origin.
The Japanese space agency JAXA has recognized how interesting the object is and is sending its Hayabusa2 spacecraft there. You may be familiar with Hayabusa2. It has already collected samples from the asteroid Ryugu, which were then successfully returned to Earth, one of the most celebrated space missions of recent decades.
I spoke about the whole asteroid-comet topic with ESA scientist Dr. Michael Kuppers, a full-time comet researcher. How cool is that? And I asked him about the difference between asteroid and comet missions. Why even bother trying to find such a special comet? We could just take an asteroid instead. And there are plenty of those in the inner solar system, like sand on a beach, roughly. Yeah.
And they're much easier to reach. And we've already seen a few of them. But asteroids, unlike these comets, are very heavily processed. For one thing, they're closer to the sun, so more changes simply because of the heat. And on the other hand, asteroids mostly come from the asteroid belt, so they've had many collisions over time and have also changed a lot because of that over time. So we really don't see the material as it was at the time of its formation anymore.
Yes, and for Hayabusa2, KY26 is now the new target. Arrival July 2031. And when the probe arrives there, it could make a pretty surreal discovery.
Planetary scientist Dr. Santana-Ros, who remeasured the object last year, has discovered some very strange things and says, the object looks completely different from what was expected. It is much smaller, rotates twice as fast, and is considerably brighter than expected. Rocks in space are usually dark because they absorb sunlight heavily. KY26, on the other hand, reflects light unusually well. Its so-called albedo value is around 0.52, which is extremely high. Metallic surfaces, such as those of a space probe, would explain this. And this is precisely where the authors of a new study come in, as a research group from Harvard University's Initiative for Interstellar Studies has put forward a hypothesis that packs a punch.
KY26 is not a natural asteroid at all. It could be a man-made object, an artificial space probe. But we can turn off the X-Files music now because we're not talking about an alien space probe, but a lost Soviet space probe, which doesn't make it any less strange. Its name, Phobos 1.
On July 7th, 1988, the Soviets launched the Phobos 1 probe towards Mars. The target, as the name suggests, was the Martian moon Phobos, an extremely ambitious undertaking at the time. Weighing around 6,200 kilograms, the probe was one of the heaviest interplanetary probes ever sent into space. Yet barely 2 months after launch, an error occurred that ranks among the most curious mishaps in the history of space travel. A ground controller sent a faulty command sequence to the probe. A single misplaced hyphen in a single command caused the attitude control thrusters to be deactivated. The probe could no longer orient its solar panels towards the sun.
Power gone, contact lost, Phobos 1 was lost. somewhere in no man's land between Earth and Mars because of a single wrong hyphen. Any experienced programmer among you can probably relate to that very well. But what happened after that? That's exactly what the authors of the new study are asking. Their answer: the probe's autonomous propulsion system may have ignited after contact was lost.
Whether by accident or due to residual signals in the onboard computer. Shortly afterwards, on September 22, 1988, the European Southern Observatory at Moscow's request attempted to locate Phobos, one at the predicted location. No such luck. The probe was not where it was supposed to be. The suspicion at the time was that an unintended engine ignition had thrown it off course. The researchers have now run this hypothesis through modern trajectory calculation software. The result is remarkable. According to the study, the orbits and positions of Phobos can be reconciled with those of KY-26 if two changes in velocity are assumed. A first maneuver shortly after contact was lost in September 1988 and a second in May 1996. The authors write, "We found that two propulsion maneuvers with a combined delta V of 1.9 kilometers per second bring the orbits and phases of the two bodies into alignment, with an arbitrarily small separation in the six-dimensional phase space. In other words, if the probe fired its engines twice, it would, mathematically speaking, end up exactly where KY-26 is today. And Phobos 1's fuel reserves would even have been sufficient for this, as the mission was aborted just a few weeks after launch and the tanks were still almost full." The other characteristics also fit together remarkably well. KY-26 is about 11 meters in size. With its solar panels extended, Phobos 1 had a wingspan of around 10 meters, and the extreme fluctuations in brightness when observing the object suggest a very elongated shape. So not a spherical rock, but something with outstretched arms, just like a space probe with solar panels. The study summarizes the combination of a high albedo value, a diameter of 11 meters, and a rotation period of 5.35 minutes suggests a small, robust, monolithic object, such as the Phobos 1 probe would be. The researchers themselves emphasize that none of this has been proven yet. The study is a so-called preprint and has not yet been peer-reviewed by other scientists. The majority of the scientific community still seems to assume that KY-26 is a natural body. There are AI-assisted 3D reconstructions of the object that suggest an irregular shape typical of an asteroid, and yet the authors have listed several pieces of evidence all pointing in the same direction. Size, brightness, shape, orbit, fuel capacity. We will know whether this is the truth in 2031. By then, Hayabusa2 will be right there on site. And just imagine that, a Japanese space probe landing on a Soviet space probe that has been drifting forgotten through the solar system for almost 40 years.
That would be the strangest, the most poetic, and the most absurd thing space history has seen in a long time. And somehow I would find that absolutely beautiful. In asteroid and comet research, however, many more exciting missions are planned until then, as Dr. Keppers has reported to me. What other projects should we keep on our radar? We've just talked about Rosetta, which is already over. Comet Interceptor, what else do we have?
Yes, well, we also just mentioned Hera.
Yes.
And then we have, as a follow-up mission to Hera, or as far as possible, a copy of Hera, which we are currently studying in detail via the Ramses program. And if that receives full funding now, at the end of this month, during the ministerial conference it will then accompany Apophis as it passes by in the year 2029, 30,000 kilometers from the Earth. That is Ramses itself, which would orbit the asteroid. And then there would be two CubeSats again, so 30 by 20 by 10 centimeter microsatellites. And one of those would have a radar to investigate the interior. And the other one is intended to land with the seismometer as the main instrument.
Amazing. When is that planned for the flyby then?
Yes, for the flyby. So the launch would be in 2028, around April or May. And the flyby of Apophis is then in April 2029.
I will, of course, keep you updated as soon as there are new findings. Maybe we'll even do a little live stream in 2031 when Hayabusa arrives. Subscribe to the channel now so you don't miss it. And remember to give a thumbs up so we can hit 5,000 likes. Yes, and there was even more exciting news in the world of science this week.
And the craziest news is all about Ötzi, the famous glacier mummy from the Alps. And now scientists have discovered something alive inside him, something that is actually still alive and thriving, and the craziest thing is the scientists ate it. You can find out all about this mad story and see lots of exciting original footage of Ötzi in the video shown at the top right. As always, there's another topic on science and space in the bottom right hand corner. And apart from that, I'd say see you in the next video. Take care, everyone.